Hello everyone. In this video, we're going to start talking about lesson 2, which is graphical and numerical summaries. So, uh, to describe what we did or what we ended on last time, uh, we talked briefly in lesson 1 about describing categorical variables with summaries or statistics, and we noted that it's very hard to talk about categorical variables because there is no sort of distance between the categories. And so all that we could do was count them, and then, of course, we could find proportions by dividing the counts by the total, and then we could turn that into percents. And so we did that last time, and we summarized them in a frequency table as such we see here for the IRIS dataset. Now we can also describe categorical variables graphically, and we will do so in 3 different ways. So to describe them graphically, and what I mean by that is make graphs or plots of them, we're going to make bar charts, pie charts, and Pareto charts. You probably know what a bar chart and a pie chart are, and a Pareto chart is probably new to you, and so I'll discuss them very quickly in this slide. So we're going to talk about pie charts, bar charts, and Pareto charts. So here's a pie chart. You probably know what a pie chart is, at least vaguely. They take the proportions that you find in a frequency table and make that the proportion of a whole, where the whole is a circle. And so portions of this circle correspond to, or portions of the pie correspond to different categories of the categorical variable. Now, I will note that a lot of people believe that pie charts are not a very good representation or not a very good graphical summary. Even though they are very popular and you see them all the time, it's generally a no-no to make them because it's hard for humans to see or tell differences in angles. Okay, so for instance, if I took away the percentage in grapes and in bananas on this pie chart, would you be able to tell me for certain that the dark blue portion of the circle is bigger than the yellow portion of the circle? After you look at it for a while, yes, you probably can, but it's not immediately obvious, and that's a problem. So a better chart, and possibly even more popular than a pie chart, is a bar chart. And in a bar chart, the height of the bar represents the count of that category. Okay, so that's a bar chart. Great. And the last one is a Pareto chart. Okay, this is what a Pareto chart looks like. It looks very much like a bar chart, and in fact, it is a bar chart. It's a special kind of bar chart where the highest bar, or the bar with the most counts in them, is first or the leftmost, and then it decreases as you go to the right. So another way to say that is that they're sorted in descending order, with the largest first. When a bar chart looks like that, it's called a Pareto chart. Okay. Now, what about numerical or quantitative data? Okay, we can summarize those graphically as well. Okay, and the book talks about 3 of them: the dot plot, the stem and leaf plot, and the histogram. We're going to forget about the stem and leaf plot because we're not in middle school anymore, and we're only going to talk about the dot plot and the histogram. So, this is what a dot plot looks like. And a dot plot is very simple in an idea. You place a dot at the value of that variable. So in this plot here, we see we're plotting the displacement of an engine in a car. Okay, it's in a fuel economy data set that you will work with very shortly. And so we're talking about engine displacement here. If I had a car that has an engine with a displacement of 4, whatever that means, there is cubic whatever, there are units associated with that. If I had an engine with a displacement of 4, I'd place a dot at 4. Okay, and When you have repeats, then you place the dots on top of each other, and so you can see where more often the dots will lie. And so that is a dot plot. A dot plot is very good for small data sets when you only have 50 observations or 20 or 10. A dot plot is great. However, when you have many observations, for instance, if I sampled 100,000 cars and looked at their displacements, engine displacements, there would be a lot of dots on this graph. And it wouldn't tell you much because the dots would be too small and the picture would be very odd. Okay, so dot plots work well for small data sets. When you have large data sets, you need to turn to a histogram. A histogram. This is what a histogram looks like. It looks very similar to a bar chart, except the bars are now touching each other. In a bar chart, there's some distance between the bars. Here, there's no distance, and that's for a very specific reason. So a histogram takes quantitative data, which possibly has many or infinite values in it, infinite possible values, and it bins them. It bins the data together to, in a sense, make a number of different categories which data could fall into. Then it counts all the data and puts them into those categories, and that's what makes the height of the bar. Now, that might have been a confusing explanation. I'm going to have you read. There's going to be a reading assignment in a few slides in which I want you to read through the chapter, and in the chapter they describe in detail how to make a histogram. Now, I'm not going to make you make a histogram by hand, okay, because I personally find that to be a useless skill, okay? But I do want you to understand how a histogram is made. And so in the book, they describe how to make a histogram. I want you to pay special attention to that part so that you understand what a histogram is. But I'm not going to ever make you do it by hand. Okay. So when looking at a bar chart or a pie chart or a Pareto chart, the displays for categorical data, you can't say too much about them. Meaning you can describe general patterns. You can see which one occurred more often. You can count them basically. And that's about all you can say. When you're describing quantitative data and quantitative graphics or graphs or plots, you can say quite a bit more. And so there's three characteristics or three classes of characteristics that we're going to talk about. And those are shape, center, and variability. Okay, so I can talk about the shape of quantitative data. I can talk about a usual value or a typical value of quantitative data. That's what I mean by center. And then I can talk about how spread out the data are. And that I'm going to call variability. So let's first get into shape. So there's a number of things that I can do to describe the shape of the data. And much of it comes from looking at the plots. Okay? And so the first is modality. How many modes does the data have? Okay? How many modes does the data have? I'm missing a does in my slides here. A mode is what occurs most often. Okay? And so in a plot of the data, you'd see that as a hump, or there are many different names of it. Okay? It's the most frequent occurrence. So you can have a number of different ones. You could have one mode, and we're going to call that unimodal. We could have two different modes, and they call that bimodal. And then once you get to more than two, Uh, you could call 3 trimodal, so on and so forth, but generally after 2, you're going to call it polymodal. Okay, so we could talk about the mode. How many modes does the data have? And then specifically in the shape, I can look at how the data looks as a whole. And so one thing I'm interested in the overall shape is it symmetric? And so you've probably heard of this word before in a math class. It has a similar meaning here in a stats class. When I call something symmetric, each side of the data around the center is a mirror image of each other. So once I pick the center of the data, and we'll talk about how to do that how to do that after this. Once I pick the center, and I could pick the center in a plot, if I fold one side of the plot over on itself, it should look roughly like a mirror image of the other side. Okay? Or if I flip it over, it should look like total overlap. All right? So symmetric. And we'll see lots of examples of symmetric data. Now, a difference between statistics and mathematics is that things can look, when I mean symmetric, I don't mean, I mean the definition here, but things can be roughly symmetric. Okay, or good enough for some purposes. It doesn't need to be exact like a math class. It can be roughly here because we're dealing with real world things, and real world things are often dirty or messy or not exact. Okay? So if that didn't make sense, any of my babbling there, then just rush past this part. Now, if things aren't symmetric, they're called skewed. Okay? And so skewed means that one side of the data, or the distribution of data, and we'll talk about what distribution means a little later on, stretches out farther than the other side. Okay, so I have a few examples here of what skewed looks like. Now, you can be either skewed right or skewed left. Okay, and so what I'm going to ask you to do, or what you would be tasked to do on an exam or homework, is I would give you a plot of the data, and then I'd ask you if it's symmetric or if it's skewed, and if it's skewed, which way. So here are 2 plots of data. Each show different types of skewness. So if we look at the left plot first, you'll see that a bunch of the data, or most of the data, lies on the left side of the plot, okay? And then you see that the data trails off to the right. There are a few values at 3, but most of the values are close to 0. So we would say this data is skewed right because the direction of the skew goes in the direction of the tail, okay, or where the data trails off to. And so you see that the data trails off to the right, and so skewed right. Skewed left is the exact opposite. Most of the data is on the right of the plot, and the tail goes to the left. Okay, so here's your first reading assignment. I want you to read section 2.2. It goes over in more detail what we just did, okay? So pages 32 to 46. You can access the book through MyLabs Plus, okay? And so when you do, I want you to skip the stem and leaf plot section and the time plot section, okay? There are a number of things that we didn't go over here that the book does go over, okay? So there's a reading assignment, and after you're done that, I want you to try to make some plots, okay? Or to graph some data. So I give you directions here. In the Lesson 2 content folder on D2L, there's going to be a data set called Fuel Economy. I want you to download it, load it into StatCrunch or Minitab, and then complete the following. Make the histogram of highway, bar chart of drive, and pie chart of cycle. So each of those is a name of a variable in the data. Okay, I want you to make those 3 plots. I have a separate video called Intro to StatCrunch or something like that that I've posted as well with these slides, with this video, so on and so forth slides, that goes over how to access StatCrunch, how to load data into StatCrunch, and how to make plots. Okay, so consult that in doing this.